Oh, come back already. Okay, one more. Right. Now, earlier on, I told you that the formula is probability of x equals to r. NCR e to the power r q to the power n minus r. So what is the meaning of this formula? It means that first of all, from you read the question. From the question, you must know number one, what is the Bernoulli's trial? What is the probability of success? Probability of failure? Then the second one is how many times is this success failure experiment repeated? Okay, how many times is repeated? Then the third one, what is the x? Okay, x means what, you know? Never mind. Okay, okay, right? Go tuition. Okay, so how many times is it repeated? Okay, sorry, how many times repeated? Then the third one is what is the value of x? The discrete random variable. That means the number of success. Numbers of success can be 0, 1, 2, 3, 4, 5 until n. Until n. That is the value of x. Okay, so now we look at this question here. Li Ying, you read this question number 3. Question number 3.
There are 2 basketballs and 4 footballs in a box. If 4 balls are randomly drawn from the box one at a time. After the type of ball is recorded, it is returned to the box. If S represents the number of basketball being drawn from the box, draw a probability distribution graph for X.
Probability distribution graph. They didn't ask to draw the tree diagram, right? Not so no need to draw the tree diagram. Straight away you draw the bar chart. X equal to 0, x1, x2, x3. What is the height of the probability? Now here they say x represent the number of basketball being drawn. So if you draw the basketball, that means you are success. Can you tell me what is the probability of drawing a basketball? Can you tell me what is the probability of drawing a basketball? How many basketball are there?
Uh, 2.
How many balls are there all
2
together?
basketball. X.
6. So what is the probability of drawing a basketball?
1/3.
And you said 2, then you said total 6. How can it come?
1/3.
1/3, correct. Because it's 2 basketball,
Yeah.
then altogether 6, right? So 2/6 is 1/3. So this is the probability of success. Drawing a basketball is success. Okay, then what is failure? Failure is drawing a football. Football, then you take 1 minus 1/3. Always like that one. For binomial distribution, for Bernoulli's trial, only 2. Success, failure. So if probability is 1/3, the other one is 2/3. 1 minus 1/3 is 2/3. Always like that, right? So how many times is the experiment repeated? How many times?
Pardon, teacher?
How many times, let's say you draw one ball, this is football, or you draw one ball, this is basketball. So this is the Bernoulli's trial, right? You just draw one ball is one Bernoulli's trial. How many times is this repeated? Draw again, draw again. How many times?
4.
4 times, because they say 4 balls are randomly drawn. So it's repeated 4 times. So it means that n is equals to 4. If n equals to 4, what is x? Can you tell me what is x? 0? 0 then? What is the value of x? Now we know value of n is 4, right? What is the value of x? X represent the number of basketball drawn from the box. What is the value of X? 0? Can it be 0? Can it be 1? If you see the n equals to 4, then the X is 0, 1, 2, 3, 4. This is the R already. This is R, X equal to 0 is X equal to 1, X equal to 2, X equals to 3, X equals to 4. So X can be 0 to 4. Okay, right. I want to tell you that this one is actually a binomial distribution. The X here is actually distributed binomially with n equals to 4, p equals to 1/3. Okay, now this is the probability of x equals to r is NCR p to the power r q to the power n minus r. I want to come back to this again. How to read this? How to read this? X is actually referring to this x here, the discrete random variable. Okay, it's the discrete random variable. How to read this? Okay, it's read like this. It's read like this. X is distributed binomially. X is distributed binomially with n equals to 4 and p equals to 1/3. P equals to 1/3. Okay, so this is how you're going to read this thing here. Now this notation here is not my invention. This one, you go to all the textbook. This is how they write a binomial distribution. X is a discrete random variable. X is the number of success. And this number of success, this curly line there, the curly line there, they say X is distributed, B is binomially with n equals to 4 and p equals to 1/3. Okay, this 4 here is n and the 1/3 here is p. Okay, so this thing can be written for all binomial distribution, and this, the way of writing this is not my invention. The way you write this is all the textbook, they write it this way. Okay, so you learn how to read this symbol. Okay, so it is read as this. You read it like this, right? X is distributed binomially with n equals to 4 and p equals to 1/3. Okay, this is how you read. Okay, now in order to find the probability of x equal to 1, x equal to 2, x equal to 3, you just, if x equal to 0, you substitute 0 here, substitute the 4 here, 0 here, then the p, 1/3, 1/3 to the power 0 here, then q is 2/3 to the power of 4 minus 0. So that's how you're going to use the formula. So we look at the first discrete random variable, x equals to 0. So the probability of x equals to 0 is n choose 0. N is 4, so it's 4 choose 0. Number of success 1/3 is 0. Where this number 0 come from? Come from here. Come from here, right? So here's 0, this number is 0. Here's x equal to 0, this number here also 0. How to get this number? This number is 4 minus 0. 4 minus 0. 4 minus 0 is 4. So it's 2/3 to the power 4. 4 choose 0 is 1. 1/3 to the power of 0 is also 1. So all this 4 to the power of 0 of 4 choose 0 is not 0. It's 1. 1/3 to the power of 0 is not 0. It's 1. So we have this probability 16/81. 2 to the power of 4 is 16. 3 to the power 4 is 81. So the value is 0.1975. Okay. Now, can you tell me what is the probability of x equals to 1? X equals to 1.
4
Yeah.
choose 1.
4 choose 1, okay.
1
Then,
over 3 to the power of 1.
okay,
2 over 3 to the power of 3.
not 3. 4 minus 0. Oh, so 4, yeah, 3, sorry. I look at the wrong one. Okay, it's correct, okay, to the power 3. So 4 choose 1, 1/3 to the power 1, 2/3 to the power 3, correct. So how to find 32 over 81? How to get 32? This is 4. 4 times 8. This is 8. 2 to the power 3 is 8. So it's 32. The bottom is 3 here, 3 here, 81. Okay. How about the next one? X equals to 2. How to find the probability of x equals to 2?
4 choose 2.
4 choose 2,
Bracket
correct?
1 over 3 to the power of 2. 2
Correct.
over 3 to the power of 2.
Correct. Okay. So use your calculator lah. Yeah, I think you know how. Anyone don't know how to use the calculator? Never mind. Afterwards, I make one video, one short video, how to use the calculator. Then I show you how to calculate this number, right? Okay. So the value is 24 over 81, 0.2963. Okay, next one is x equals to 3. Even can do or not? X equals to 3. 4c, you type there on the chat there. 4c. Yeah, correct. Then 1/3 to the power of how many? 1/3 to the power of 3, correct. 2/3 to the power of how many? 1, correct. So that is how you do this probability distribution. So x equal to 3, and this is the number, right? Answer 8 over 81. Okay, last one, 4c4, 1/3 to the power 4, 2/3 to the power of 4 minus 4. So you get 0 here. 4 minus 4, that's why you get 0. And the answer is 81. Then all this probability, the blue numbers here, the blue numbers, and you copy and put inside one table. So x equal to 1, 1975. X equals to 1, 3951. X equal to 2, 2963. X equals to 3, 0988. X equals to 4, 0123. Right? So this one, we're going to plot the graph, and the graph is like this. The table is here. Right? So you plot the graph, and this is the graph of the probability distribution. Why they use the word distribution? Distribution means you distribute it. This is the probability. I distribute them. 0, nah, this is how much you get. X equal to 1, this is how much you get. X equals to 2, this is how much you get. X equal to 3, this is how much you get. X equal to 4, this is how much probability you get. So you distribute, you give them the probability. 0, 1, 2, 3, 4. So this is the distribution of probability. So binomial distribution of the probability, right?